Hi, I'm Tristan Worthy.
I'm Nathan Rouse.
Welcome to BlastMasters.
It's good to see all of you again.
And we're here to talk to you today about some simple calculations to take a greenfield operation into blasting excellence.
That's right, these are really basic calculations, back a napkin type of calculations that you can really do anywhere just to make sure you're in the ballpark of where you need to be.
And for all your basic blasting calculation needs, International Society of Explosive Engineers is a good resource to go to. As part of a member, they give you a very nice, simple calculation sheet, and we're gonna go over some of those calculations today.
That's right, and those calculations are all based on Ash's burden calculations, which you can find in other sources as well, and we'll show you really quickly how to work through those.
And it's cool because all you need to know is your geology on site and a hole diameter, or potentially what type of bench height you want.
That's right.
Let's get to calculating.
Yeah.
Ash's burden equation has quite a bit of variables, so we'll set some groundwork at the beginning and go through those variables. So some of the known variables that you'll need to determine is D, and that is diameter of explosives. Don't think it's just hole diameter, because some explosives doesn't fill the whole diameter of the hole. The next variable you'll need to determine is rock type. Now this is not really a rock classification like a type of rock, but it's hardness from soft to hard. And then the last thing you'll need to know is the energy, or the explosive's energy, and that is from low energy to high energy. Some of the unknown variables that we're going to calculate with the known variables is B, which is your burden, KB, which is your burden factor, H, which is the hole depth, KD, which is the depth ratio, J, which is the subdrill, T, which is the semi, S, which is the spacing, KS, which is the spacing factor, and then lastly L, which is your bench height.
Now let's run through these bad ash equations. Starting, we will calculate burden. We use the known charge diameter and multiply times the burden ratio, and then divide the product of those two values by 12. To find the burden ratio, we need to know whether the explosive energy is low, average, or high, and whether our rock type is soft, average, or hard. For borehole depth, we calculate the borehole depth as the product of the depth ratio times the burden. The burden we just would have calculated, and the depth ratio ranges from 1.5 to 4. For subdrilling, we multiply the burden times 0.3 to find the subdrilling depth. Stemming is found by multiplying the burden by 0.7. Spacing is found by multiplying the burden times a spacing factor, which ranges from 1 to 2 if 1 if you have long delay intervals, 2 for simultaneous initiation. For short delay intervals, the spacing factor ranges from 1.2 to 1.8. And then finally, the bench height is calculated by subtracting the subdrill from the borehole depth.
Now we're going to put these bad ash equations to work and work through an example. So we're working on a mine site, and our drill foreman, he gets a burrito every time he buys a 6-inch hole. So every pattern we have has got to have a 6-inch hole, and we're using a bulk explosive, so our explosive diameter is 6 inches. Okay, so now we need to determine our burden ratio. We have an average rock hardness, and we also have average explosives energy. So our KB factor is going to be 30. Once we know these variables, we can calculate burden by multiplying our KB factor of 30 by our hole diameter of 6 divided by 12. That will give us a burden of 15 feet. Once we know our burden, we can determine our borehole depth by taking a depth factor of 4 times our burden, which will get us a borehole depth of 60. Then moving on to subdrill, we will take 0.3 times our burden of 15, and that will get us 4.5 feet of subdrill. Moving on to stemming, we're using the stemming factor of 0.7 times the burden, which is 15. That gives us a stemming length of 10.5 feet. Then to the spacing, we did read a research paper done by the Swedish that determined that the best factor for spacing is 1.4. That gives the breast fragmentation. So we take 1.4 times the burden of 15, which gives us a spacing of 21 feet. To determine face height, we then take our hole depth minus our subdrill, 30 minus 4.5, to get 55.5 feet. Now we have all the basic parameters we need to give to our drill foreman, give to our blast foreman, and they can go out, drill, and shoot a blast. Now we can calculate powder factor if we know the explosive density. Also, if you want to start off with a bench height instead of a explosive diameter, you can do that and back calculate your way to an explosive diameter and a burden. Now that's a wrap. That's all the equations we have for you today.
That's right. We appreciate you listening and going through them with us, and hope you enjoyed it as much as we did. And stay safe out there.
And more importantly, stay safe. Now, wasn't that a blast? Those were some sweet blasting equations.
Yeah.
Yeah, we love equations and we love blasting.
I love equations.
We're here to talk to you. Take care, and we'll see you next time on BlastMasters.